cutie patootie math angel. Welcome or welcome back. This is Decaf-Math, ASMR. I hope that this finds you well. Today we are going to take a nice, gentle look, dare I say relaxing look at some SAT practice problems. So since the SAT is a standardized test, usually these would be done in a timed environment. But today we don't care. We're going to take as much time as we need or want. We're going to be patient and kind to ourselves. And we're just going to hang out and relax. So today, it does not matter how much you know or don't know. You're just going to see where there might be some gaps. Take this one concept at a time. And I'll likely make this into a series. And so go at your own pace. For worrying does not change anything right here and right now, right? So we're just going to be present. And even if you're not reviewing for the SAT or don't even really care for the math at all, you can just sit back, zone out, or even drift off to sleep if you need it. So let's get comfy and cozy. Ready to get started? Okay, very good. So here's the first question. I see a list of numbers, and the question says, which frequency table correctly represents the data listed? And this is a multiple choice question, right? So I'm going to underline some of the key ideas here. We are picking a frequency table that represents the data listed. So in this case, we have a list of numbers. So our data is numerical. So specifically 4, 4, 4, 4, 8, 8, 8, and 13, 13. Okay? But they don't have to be numbers. They can be descriptions or categories or something like that, other types of data. The key part of a frequency table, or the key idea, is that we're basically going to list out the unique values or the unique data points, and then we are going to write out how many times each of those data points show up, aka the frequency. So how many copies of them do we have? So first we want to write out the different possible values under this number column. So here we have 4s, 8s, and 13s, and nothing else, right? So I should see 4, 8, and 13 under this number column. So A is a possibility. For this column for B, I have 4, 3, and 2. So that's not quite right. I see the 4, 8, and 13 in the wrong column, so I can eliminate B. For C, I see the 4, 8, and 13, so that is a possibility. And for D, we have 4, 8, and 13 in the wrong column as well. We see 16, 24, and 26 under the numbers. So straight away, we can eliminate choices B and D, which is pretty good, right? That's half of our answers, so that's a good start. So then next we want to represent or write out how many copies of each of those unique values we have. So for this list, for 4s, we have 1, 2, 3, 4. We have 4 4s. So for answer A, we have 4 4s. For 8, we have 1, 2, 3. We have 3 8s. So that 3 for frequency represents 3/8. And then we have 1, 2, 2 13s. So here we have 2 13s. So frequency just means how many of them do we have. So answer A is our correct answer. Let's take a little peek at C, because that was our other possible answer with our 4, 8, and 13, and see what's going on. So for C, I see a frequency of 16 that corresponds to this 4. That would mean that we would have 16 4s. So if I were to write this list out, I won't write every single one, but it would be 4, 4, 4, 4, 4, 4, dot, 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 16 of them. 16 4s, comma, and then I'd have to have 24 8s. So 8, 8, 8, 8, 8, 8, 8, dot, dot, dot. So we'd have 24 8s. And then we'd have to have 26 13s. So this is a much, much larger list of numbers. Does that make sense? So A is the correct one, and I believe, as I'm looking here, 16, 24, and 26, it looks like they just tried to add the numbers. So they did like 4 times 4, 4 4s is 16, 3 times 8 is 24, so 3 8s is 24, and 2 13s is 26. So it looks like they just added, maybe they were mixing up the idea of times, so we won't let that throw us off. Imagine if this list were a list of animals or something. So let's say dog, 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 zebra, 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 hippo, hippo. We wouldn't add any values together, right? We would simply put the unique values or unique animals in this first column, and then we would write the corresponding number of each we have in the second column. So there's no adding or anything like that. So A is the correct answer. You did an excellent job. Okay, ready for the next question? Question number 2. Which expression is equivalent to x squared plus 3x minus 40? And again, this is a multiple choice question. So we can see here in each of our possible answers, we have something multiplied by something, stuff times stuff, and more specifically, it's a binomial times a binomial. So we have 2 terms, binomial, separated by a minus or a plus. 2 terms separated by a minus or a plus. So when we have a binomial times a binomial, we typically use the FOIL method to expand that. And so you can do this 2 ways. You could look at our expression and factor it into our binomial times binomial. So it's basically the backwards of the FOIL method. Or you can just multiply each of these out and see which one gives you this. So it really just, in a timed environment, comes down to which one you're more comfortable with, which one you feel like you're faster at. So let's actually here, this isn't going to be like a full in-depth lesson, right? But for the sake of review, let's go ahead and factor, since that's kind of the general direction here, right? If you are comfortable with factoring, that would probably be the faster way to do it. So for the sake of review here, we're going to factor this. Now, if as I'm working this out, you are a little confused, I do have other videos on factoring and the FOIL method. So the thing is, when we are reviewing, I just want to leave you a little love note here. When reviewing, it should be just that. If you're trying to learn while also reviewing, you might, of course, feel a little overwhelmed. So if at any point this feels kind of confusing to you, that just means you gotta take a little bit of time to go over this concept, okay? So we're just going to use this as a little roadmap to see where you need more practice. But otherwise, play along, follow along, and let's see what factors we get. So first of all, let's see here. So the nice thing about this quadratic is that the coefficient is 1 in front of the x squared. 1 times anything is itself. So if we had, for instance, 4 or 5 or 6 or whatever coefficient, we would also have to factor that number. But because it's 1, we know that the two binomials are just going to be x and something and x and something, because the only way to factor 1 into positive whole numbers is just 1 times 1, right? So x times x is going to give me the x squared. So that's actually really nice, and we can see that in all of our multiple choice answers. We have x, and then we just need to figure out the second parts, right? So with the FOIL method, we are doing first, outer, inner, and last. So the first part is taken care of with the x times x. Then let's take a look at the last part. We can deal with the outer and inner later. The last two numbers, so the second two numbers, have to multiply to give me negative 40. Now in order to get a negative product, one of these numbers has to be positive and the other has to be negative. It doesn't matter which one as you write it out, as long as you are consistent with your actual factors. But I am looking at our possible answers here, and they do all negatives for the first one and positive for the second, so I'll just do the same there, just for consistency here. So a negative times a positive number is negative, so that's going to be for our negative 40. So now we just have to factor out 40. So we're finding pairs of factors. So for instance, theoretically, it could be 1 and 40. Let me do this in a different color, actually. So theoretically, we could have 1 and 40, because 1 times 40 is 40. We could have 2 and 20. 2 times 20 is 40. Not 3, but we could have 4 and 10. 5 and 8, right? Not 6, not 7. I believe that's it. And then we can flip them the other way. We could have 8 times 5, 10 times 4, 20 times 2, and 40 and 1, right? And so those are the pairs of whole numbers that multiply to give me 40. So those are factored and they are pairs. So these are possible numbers, but that takes care of the last part, the L part of our FOIL. But we also need outer and inner, which means that this number times x and then minus this number times x, so we add them or subtract them based on the sign, should also give me this middle positive 3x. So you can try each of these pairs. I'll say right now that it would be 8 and 5, right? Because 8 times x is 8x minus 5x is positive 3x. So 8x minus 5x, that's the O and the I part for FOIL, and that gives me positive 3x. So our answer is x minus 5 times x plus 8. Okay, so let's look at our possible answers here. Not A, we have x minus 5 times x plus 8, so that would be B. And C is kind of tricky. They switch the minus 5 and plus 8 to minus 8 plus 5, and then D is incorrect as well. So I hope that that makes sense. And if you want to do a quick little check for the other answers, it really just comes down to our outer and inner for these answers, because we do have x times x is x squared, and negative 4 times 10 is negative 40. Negative 10 times 4 is negative 40. Negative 8 times 5 is negative 40. But it just comes down to our outer plus or minus our inner to get this 3x. So for the first one, for instance, we have 10x minus 4x, so that would be 6x. Our B is correct. We have 8x minus 5x is plus 3x, so that's good. We have 5x minus 8x is negative 3x, not quite. And then we have 4x minus 10x is negative 6x. So that's why the other ones are incorrect. And B is our answer. Excellent, excellent job. Okay, here is question number 3. You're doing great. So this looks like a word problem. So as we read word problems, we can underline or highlight information that we think will be helpful. So we'll just do this bit by bit. Jay walks at a speed of 3 miles per hour. Walks at a speed of 3 miles per hour and runs at a speed of 5 miles per hour. This helps me focus and not just get lost in all of the words or trying to translate everything into math here. So we have speed for walking and speed for running. And then it says he walks for W hours and runs for R hours for a combined total of 14 miles. So this is a total distance. And I also have some time here, right? So he walks for W hours. So that's a time. And he runs for R hours, and that's a time. Even though W and R are variables or letters, they just represent the number of hours he walks or runs, respectively, right? So then the question is, which equation represents the situation? So we have multiple choice answers again. So let's just come up with an equation on our own and then take a look at the answer so that we don't get confused or influenced. So here it says we have some speeds, times, and total distance. So that looks to me like we want to represent everything in terms of distance. So basically, distance walked plus whatever the distance he ran should equal total distance, which is 14 miles. Because that's what it says here, right? Okay, so then now it just comes down to breaking down D walked and D ran, right? The total distance for each. So we'll do this step by step. D walked, so what is the distance, the total distance that he walked? So it does say that Jay walks at a speed of 3 miles per hour. So that literally means for every 1 hour of walking, Jay would have walked 3 miles. This is a proportion or a ratio in a way, right? So for every 1 hour, so that means that 3 miles for every 1 hour. Literally 3 miles per hour, right? But then it says that he walks for W hours. So all you have to do is multiply that by W hours, like this. And so that just gives you 3W. 3W, right? So you can think of this as speed times time. And you can kind of think of it as canceling out the units there, the hours and the hours. That's like a little trick you use in chemistry too. It's a little sketchy because these are just units, but it does help you make sure that you set up your ratio or your scaling correctly instead of, dividing or just getting mixed up with, what you're actually multiplying. So we have distance is speed times time, or rate times time. It's a formula we're using here, and we're not really doing physics or anything like that, so we're not really focusing on direction, so it's just going to be straight up linearly speed times time. So we have 3w for distance walked, and then for distance ran, we do the same thing. His speed is 5 miles for every 1 hour. And so if he ran or runs for r hours, that means that he would have run 5r miles. So we can just make sure that our units are good too. So this should be not divide here, but like miles. 5r miles, right? So notice here that our expressions here contain w and r, but we don't actually have to know what those values are. These are just expressions to represent the distance walked and the distance run. So it could be half an hour, could be 5 hours. It doesn't matter here. These are just general expressions. So for d walked, we have 3w. So that's 3w plus, for run, it's 5r, and the total is 14. So notice we have miles plus miles is miles. So this is our expression, 3w plus 5r equals 14. So that would be answer A. So I would just trust, if we do this step by step, that we'll get to the right answer. It looks like they're just kind of trying to throw us off with 1/3 instead of 3, 1/5 instead of r. And for D, I'm not sure where the 112 comes from. They might be doing some fancy math here or something, but we can be confident in our first answer here. So I think the important thing is to make sure we have these ratios correct, or instead of just memorizing distance as speed or rate times time, we can kind of just understand conceptually, right? Like something per hour means for every 1. So we're just setting up a proportion here, and I think that would keep us from accidentally, dividing by 3 instead or something like that. It'll keep our numerator and denominator clear. But if you do distance equals rate times time, just make sure you're plugging into the correct part. Okay, I think we are good here. Okay, so here is question number 4. In triangle ABC, the measure of angle B is 52 degrees. The measure of angle C is 17 degrees. What is the measure of angle A? So usually for geometry or trigonometry type of questions, I suggest sketching out to the best of your ability a possible situation or just some diagram to represent the information that you're given. But in this case, we just need to know one fact about triangles, which is that the sum of the interior angles of a triangle add to 180, no matter what the triangle looks like. So the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Okay, so it doesn't matter if your triangle looks like this, or like this, or like this. The interior angles, the measures will always add to 180. So we're just going to use that fact. It doesn't even matter how we label them. We're just going to use that fact here, and since we're given 52 and 17, we can then solve for measure of angle A. So we can say let x equal the measure of angle A. Okay, so then we would have x plus b is 52, c is 17, and that should equal 180. Now if you don't even want to do the algebra, that's technically okay too. You can just try each of these numbers and see which one plus 52 plus 17 gives you 180. But regardless, you have to know this fact, right? Otherwise you're just going to be going in circles. So if you don't want to do these steps that we're about to do, that's okay too. But just remember the sum needs to be 180. So, well actually, you know what? I take that back. If you're reviewing for the SAT, do try and work on this algebra a little bit. So 52 plus 17 is 2 plus 7 is 9, 5 plus 1 is 6, 69. So x plus 69 equals 180. And to solve for x, then you can move this over by subtracting 69 on both sides. So x equals 180 minus 69, which would be 111. So our answer is D, 111 degrees. I think that there's no real way to get around knowing that fact for this question. You just have to know that the sum is 180. And that's okay. You just commit it to memory now. You can try each of these values and add 52 and 17, see what you get. But you still have to know that the sum is 180 there. And as I'm kind of scanning this, I think 21 plus 17 plus 52 gives you 90 degrees. I think they're trying to trick you there. But I don't know. I guess if you knew that right triangles exist, right, that means that one of the angles is already 90 degrees, so it can't possibly be A, because that would make the other two 0. So that could just be eliminated, and I don't know, you could find a way maybe to eliminate each of the other answers. Maybe sketch out, these angles and make a best guess, but let's just commit this to memory now. The sum of the interior angles of a triangle is 180 degrees. Okay, and then it's just about finding the missing angle if you're given 2. Alright, ready to move on? Okay, so this is the last question for this little session. You've been doing wonderfully. So let's finish this up and take the win. And let's just keep on going, okay? So here looks like we have a graph. And it says that the graph represents the total charge in dollars by an electrician for X hours of work. The electrician charges a one-time fee plus an hourly rate. What is the best interpretation of the slope of the graph? This is actually a classic SAT question. So let's just take this step by step. So first of all, we have to recognize that the actual graph itself is this. Like, this is the actual equation or situation. Here we have an x-axis and a y-axis. That's like our setup, but this is the actual function itself, okay? So let's actually start with the axes to see what's actually going on. So for our x-axis, I don't know if you can see it, but that's an x-axis. So for here it says x hours of work. So I don't have to keep writing x's everywhere here, but it's just hours of work. And then y, for the y-axis, that's going to be the total charge in dollars. So total charge, okay, in dollars. And why do we have it in this way instead of the other way? Well, presumably for X hours of work, so like the more work this electrician does, is, presumably the more the total charge will be, and the total charge is a function. It says a function of the hours worked. So like we said, this is the actual graph of the situation. The rest is context and setup. So the graph itself is a straight line. When you have a line in the xy plane, it can be represented like this: y equals mx plus b. Does that look familiar to you? This is how we're going to bring in the idea of slope. M is the slope of the line, basically measuring the steepness and also the direction. This looks like it's going up, right? As x increases, this is going upward. So we have the slope, and then b is the y-intercept, right? The y-intercept. So we are going to interpret the slope, but I think it's easier to start with the y-intercept just to get a feel for what's actually going on here. So the y-intercept is right there. It's what is the y value when x equals 0. So that is actually going to be the one-time fee. One-time fee, as it describes here in the question, the one-time fee. Because if this electrician works at 0 hours, if x equals 0, there's still a total charge, presumably for just showing up or something, right? So that's our one-time fee. So then how do we interpret this slope? So x is still our hours, and y is still our charge. So this is basically our hourly rate. So what that means is for every additional hour of work, or for 1 hour worked, how much does this electrician charge? So it's like a rise over run question. So starting with this one-time fee, if let's say this electrician works 1 hour, it's just kind of arbitrary how you want to set these units, but let's say it's 1, 2, 3, 4, 1 hour, then the electrician will charge this much. So that's the charge. If the electrician works 1 more hour, an additional hour, and moves x that way, the electrician will charge that much. You can see this constant rate here. This is going to be a part of the charge. This is the charge. This is the charge. That is the rate of increase for every one. And for lines in particular, this slope is going to be a constant number. So that is our hourly rate. For every additional 1 hour of work, the electrician will charge the hourly rate more, right? So for 3 hours, it would be 3 hourly rates worth, right? So that the interpretation is going to be the electrician's hourly rate. Now I know it gets kind of confusing that 0 doesn't start at 0, so another way to kind of look at this, you don't have to, know this to answer the question, but just an interesting kind of way of looking at it is that if you move this entire line so that it goes to 0, but you keep it parallel, that's not very good, but you know what I mean. If you keep it parallel, you shift it down, you shift every single point down by the fee, then you literally have this graph that just goes through this 0 point. And I think it's easier to see the slope situation from that perspective, but it doesn't matter. It's just literally shifting the y equals mx graph up to b, but the slope is the same for parallel lines. I don't know if that's actually helpful, but ignore that if that didn't make sense. But that's just something that I like to think about. So you have this hourly rate, y equals mx, and then you charge the fee for every x, that you have. But anyway, the slope of the graph is going to be the electrician's hourly rate. It's not the one-time fee because that is the y y-intercept, so that would be B. The maximum amount that the electrician charges is not true. The total amount that the electrician charges is not true. So slope is always about rise over run, right? It's how steep this graph is. The total amount depends on the hours worked in general. So you would need X to know what Y is. So it's not the total amount. Anyways, that was a bit of rambling at the end, but we got through 5 whole questions, and we took our time, and we were kind to ourselves, and we can feel free to keep going, do some more practice or not. But I hope that this was helpful or maybe relaxing. Thanks for hanging out with me regardless. And yeah, we will keep on doing some more questions and jumping around with math and ASMR and math. But for now, if you are asleep, I'm wishing you sweet, sweet mathy dreams. And if you're going to continue on with the rest of your day, I hope that it's a good one. I'll see you around, okay? In the meantime, take good care. Bye-bye.